Okay, so we know that 1 volt is 1 joule per coulomb. We know that 1 amp of current is 1 coulomb per second. So if we multiply 1 volt by 1 amp, we get joules times coulombs over coulombs seconds. The coulombs cancel out and we are left with joules per second. What's joules per second? That's the unit of power. Watts. That's what we call watts. So the formula for electrical power is just voltage times current. And what power is a measure of the work per unit time. The more work is done per unit time per second, the higher the voltage and the higher the current, the higher the power. Now, what about resistors? How would that translate for resistors? So we said power is V times I. Remember from Ohm's law, we also know that V is I times R. So if I replace IR here, I get I squared R. So the power is the resistance times the current squared. Or I can do it the other way. I can solve for I here. I get V over R. I replace it here, so I get V squared over R. So for a resistor, I can use any of these 3 equations, VI, I squared R, or V squared over R, to find the power. So what does that power translate into? Translates into heat. That's what resistors do. Like friction, they generate heat. So this expression gives us a measure of how much heat per unit second that's generated by that resistor. And in either case, high current is going to result in high power, you see it here, or high voltage as well is going to result in high power.